This 10-minute video has been prepared to accompany the public exhibition of the Corowa, Howlong and Mulwala flood study. This video will focus on the town of Corowa. Videos for the other two towns are also available. The video contains information about the development of the flood study, as well as an overview of the results and applications of the study and future work. The public exhibition period runs from the 14th of August to the 11th of September 2024. The community is encouraged to provide feedback. Details can be found on Council's Have Your Say website. The study on exhibition examines flood risk within the towns of Howlong, Corowa and Mulwala. The study investigates flooding from the Murray River along the entire Federation Council border, from upstream of Howlong all the way to downstream of Mulwala. The most recent Murray River flood was in November 2022. The study also investigates local overland flooding within each of the towns, like that experienced in Corowa in January 2022. Let's have a closer look at Corowa. This is our study area. It extends from the Riverina Highway in the north through to South Corowa, including areas to the west of the town, such as the Corowa Airport and Redlands Road Industrial Area. The study investigates flooding from the Murray River as it runs along the eastern edge of the town. The study also looks at flooding from the local catchment, including runoff from the hill in the town, as well as flows in the channel surrounding Corowa Airport, and inundation from smaller local catchments through the town. These are the steps for undertaking a flood study. First is the data collection phase. We collect all relevant data, gauge records for rainfall and stream flow, flood observations, existing reports, stormwater infrastructure, terrain information, everything that we require. The next stage is to build the flood models. To build the Murray River flood model, we start with a model domain in green. We add the terrain, including details of the Murray River channel and Lake Mulwala. Then we add in structures such as bridges, culverts, and of course, Yarrawonga Weir. We then apply flow to the model for the Murray River and the Ovens River, based on an analysis of historical flow records. The model will then simulate how that flood moves through the floodplain. The overland model is built in a similar way, just with more detail. We start with the model domain, here in red, and we add the terrain, the stormwater network, buildings, and other features that control where water flows. We then apply flow to the model based on runoff that local catchment areas, such as these, will generate. And the model simulates what happens to water in a flood event. The next stage is to calibrate the models. Calibration is the process whereby we apply recorded rainfall or flows to the model, and various modelling assumptions are adjusted to improve the match against recorded data. We want to make sure the model can replicate actual flood events. For the Murray River, we can use flows recorded at Albury and input these into the model. We can then compare the modelled results with the gauge records, such as the gauge at Corowa. The 2016 event calibration results at the Corowa gauge are shown here as an example. The model water level was just 3 centimeters lower than the recorded water level. And when we look at the water level hydrograph at the top and the flow hydrograph at the bottom, we can see that the model replicates the event well. We also compare to other information, such as photographs and observations from the community, with an example shown here for the 2016 flood at Corowa. the local overland flood models, a calibration was undertaken for Corowa using the recent January 2022 storm event, where a range of data was available. Here, we can compare the model results with numerous surveyed flood levels, like is shown here. Comparisons were also made with community observations and photographs such as these. The next stage is design flood modeling. Here is where we simulate events with a certain probability of occurring that are used to understand existing flood risk for future planning and development decisions. An animation of 1 in 100 or 1% AEP flood is shown here for the Murray River. This flood has a 1% chance of occurring in any given year. The 1% AEP flood primarily affects the lower terrace at Corowa, including a number of caravan parks and playing fields, with flood depths exceeding 1.5 metres. An animation of the 1 in 100 or 1% AEP flood is shown here for local overland flooding in Corowa. You can see that the model is simulating local runoff from within the town itself. Water ponds in a number of locations, such as the Whitehead Street wetlands, on land surrounding the Corowa Airport, including Redlands Road Industrial Area, near Headerworld Avenue, north of Nixon Street near Cemetery Road, around Sophia Close, Pino Crescent, and Martin Street, as well as some areas in South Corowa and on the lower terraces of the Murray River floodplain. The last stage is actually using the results. These are some of the outputs from the flood study for overland flooding in Corowa. Flood depth and level mapping, showing how deep floodwater may be and what level it may reach. Flow velocity mapping, or how fast the floodwater moves. Flood hazard mapping, which takes into consideration depth and velocity using evidence-based research to produce categories indicating safety to people, vehicles, and buildings. And hydraulic categories, which classify the floodplain as floodway, flood storage, or flood fringe areas. This mapping was undertaken for both Murray River and local overland flooding at Corowa for a range of different flood sizes. They tell us about the flood behaviour and flood risks. These results help Council and the community to understand the existing flood behaviour and areas of flood risk, provide up-to-date flood data to end users, identify and assess potential flood risk management measures. This will be part of a subsequent project. And the results will enable future development planning, application of development controls, and assessment of flood impacts. One of the key outputs of the flood study is the identification of the area where flood planning controls apply. The flood planning area for the Murray River uses the 1% AEP results with 0.5 metres freeboard, and are shown here for Corowa. The overland results use the 1 in 500 flood results with filtering applied to get rid of very shallow inundation to focus on those areas where there is greater flood risk. The overland flood planning area is shown here for Corowa. These are the areas that, if you want to redevelop, Council can apply controls to make sure that the proposed development has considered potential flooding in terms of safety to occupants, inundation of the building, and making sure that neighbours are not adversely affected. While the flood study is currently on public exhibition, the next phase the Council intends to proceed with is the flood risk management study and plan. This is where we identify and assess potential flood risk mitigation measures, such as infrastructure, like drainage upgrades, channels, detention basins, and levees, or changes to planning controls, policies, and zoning, or flood warning, evacuation, emergency management, and community education. These are all ways in which flood risk in the study area can be reduced. The public exhibition period runs until the 11th of September 2024. The report can be accessed through Council's website on the Have Your Say page or viewed in person at Council's offices. Formal submissions are welcome. Please use the details on the webpage to submit any feedback you may have. To make a submission, please do so in writing by mail or email council@federationcouncil.nsw.gov.au. If you have further queries or would like to find out more about the study, you can attend an information session in person or online. Details are on the Have Your Say webpage.